There we are. And I'll ask all participants to mute themselves and to turn off their cameras unless you are a presenter. And this should help the discussion to run smoothly. Closer to the end of our time, I will open the discussion to questions from the audience. At that time, feel free to raise your hand, or you can also type your questions into the chat bar throughout the discussion. In 2020, the University of Manitoba signed the Global Universities and Colleges Climate Letter, publicly committing our university to take immediate action on climate change by reducing our greenhouse gas emissions to 50% by 2030 and to net zero by 2050. In 2021, the university began developing a climate action plan to better understand our baseline emissions and to plan the next steps that we need to take to reach our ambitious targets. Much of this planning took place over the summer months as Manitoba experienced one of the hottest, driest summers on record with over 30 days above 30 degrees. So today's discussion is timely indeed. I would like to begin with an acknowledgement of the territories the University of Manitoba is located on.
The University of Manitoba campuses are located on the original lands
Anishinaabe,
Cree,
Ojibwe,
Dakota,
and Dene peoples,
and on the homeland of the Métis Nation.
We respect the treaties that were made on these territories.
we acknowledge the harms and mistakes of the past.
We dedicate ourselves to move forward
in partnership with Indigenous communities,
in the spirit of reconciliation
and collaboration.
All right. Next, I would like to invite Dr. Digvir Jayas, Vice President of Research and International, to share some opening remarks.
Okay, thank you, Jesse. Hopefully you can hear me. I'm Digvir Jayas. Good afternoon. Climate change and its challenges is an important issue for the university and all of us. University of Manitoba is dedicated to advancing climate change research, and it does through that many research projects. Home to the Center for Earth Observation Science in the Riddell faculty, researchers have made and continue to make significant and groundbreaking contributions in the field of sea ice and climate change. Their research clearly indicates that climate change is not something that is going to happen in the future. It is already here. There are many impacts of our changing climate that make it abundantly clear that action is necessary. Across the country and around the world, we see extreme and erratic changes in weather that cause drought, forest fires, and flooding. An increased number of displaced peoples, and the rises in the natural disasters. Communities are responding with creativity and resilience and finding opportunities in the face of this global challenge. As we will hear from today's speakers, understanding our climate and the impact of how it is changing on every aspect of our daily life is necessary to determine how we can adapt and protect our planet. I hope you leave here with a renewed respect for the environment and those at U of M, researchers, scholars, artists, students, administrators who are working towards solutions that will benefit all. Many of you are tuned in to this discussion are here because, like myself, you care about the state of our planet. You want to learn from the leading experts in Canada about what the research is telling us is happening and what strategies there are to mitigate the impacts. Each one of us have a role to play. Thank you to each of today's panelists and speakers, and thank you to everyone who made this event possible.
Thank you. Next, I would like to invite Dr. Stephen Lima, Dean of the Clayton H. Riddell Faculty of Environment, Earth and Resources, to say a few words.
Thanks a lot, Jessie. Yeah, my name is Stefan Pflugmacher-Lima from the Riddell faculty. I think the past decades were the hottest one in human history, and apocalyptic fires, floods, cyclones, and hurricanes that are increasingly the new normal. And emissions are at the moment 62% higher now than they were when international climate negotiations began in 1990. So the evidence is very clear. We are in a race against time to adapt to a rapidly changing climate, one of the three planetary crises we face at the moment, along with biodiversity loss, pollution, and waste. I think nothing has a greater potential to reshape the life of billions as much as climate change has. We all have to understand that climate change does not know borders. When it comes to climate change, we have to think globally. From my personal point of view, I think we have 4 areas having a strategic importance in that, and these are cities, transport, energy, water resources. All of them at the moment under immense pressure due to rapid urbanization, improved mobility, rising energy demand, and water quality and scarcity. Investment into resilience can align with sustainability development goals, improving quality of life, stimulating economy, and protecting the environment while safeguarding areas against the onset of climate change. So I wish you all a very, very fruitful panel discussion. And of course, I thank all the participants for joining in here. And I thank the Office of Sustainability for organizing this. Thanks a lot.
Thanks, Dr. Lima. Now I would like to introduce our panelists. We have a great group of panelists from a broad range of departments here today. And so we're going to start by giving each panelist a few minutes to introduce themselves, share what climate resilience means to them and to their research. I'll ask Dr. Karl Ho, Associate Head of Electrical Engineering and Associate Professor in the Department of Electrical and Computer Engineering, to begin.
Yeah, thank you very much for the invitation and the introduction as well. Good afternoon. My name is Karl Ho. I'm an associate professor at the Department of Electrical and Computer Engineering, and I'm also a Canada Research Chair in Division Utilization of Electric Power. From the titles, you can see that my research is related to renewable energy and electrical devices. For the topic of climate resilience, I will focus more on electricity, energy sources, transportation, and also utilization. You may know that Canada is part of a global movement that has committed to reaching net zero greenhouse gas emissions by 2050. The possible ways to achieve the target and provide sustainable energy is electrification with renewable energy. One of the main carbon dioxide sources is our cars with fossil fuels like petrol and diesel. We use them every day and produce the greenhouse gas everywhere. Electrification means we will use batteries power our cars instead of fossil fuels. You may ask that, can Manitoba use electric vehicles? Here is quite cold in winter. I also can tell you that according to Reuters in this month, nearly 80% of Norway's new car sales are electric and will achieve 100% in 2025. That means 4 years from now. Thus, we can see that the world is changing quickly. Some people may also ask, we are shifting the greenhouse gas production from our cars to power production factories. It may be true for some countries, but still a lot of CO2 productions is in oil transportation are reduced. In Manitoba, we are lucky. We have hydropower, nearly 99% electricity are renewable energy. But if a lot of EVs, electric vehicles, that means in the province, we still need additional renewable energy sources. That could be solar energy, and it is also the way for other countries to achieve net zero greenhouse gas emission by 2050. For my research, basically, there are three main research topics in electrical power engineering. The first one is electrification. That means how can we change the fossil fuels powered devices to efficient, reliable, and cost-effective electric devices like electric vehicle and also furnace. The second one is renewable energy, how we can generate low cost, clean and also sustainable electrical energy. Example, solar and wind power. The last one, that is power coordination, how we can integrate the new sources and also loads, that means EV or furnace, into our current grids and also keep them stable. So that is the things I want to say. Thank you.
Thanks, Dr. Ho. Next, I'd like to invite Dr. Mohamad Araji, Associate Professor of Environmental Design.
Good afternoon, everyone. Thank you, Jessie. Thank you to all. And I just would like to start by really explaining briefly what the IPCC have reached just recently in Paris about the numbers when it comes to climate, and then I would delve to explain my position on how we can tackle this very briefly, as the introduction says. So as a start, I'm associated with the environmental design program. I recently moved to University of Waterloo, but I still have association with the mechanical engineering department as an adjunct professor. Have PhD students who are working on some of these topics that we will discuss today. So with the IPCC, we see that there are on average about 37 gigatons of carbon emissions per year. And this is reaching at a 0.8 temperature rise every year we have. So the target is how we can mitigate all of this by 2050. And for that, we are talking about burning about 570 gigatons of carbon. And if we look at the scope of these numbers when it comes to buildings, mobility, and industry, we see that buildings associate their numbers with about 50% of that. So we are responsible about 230 gigatons of carbon emissions that we have to bring down to zero in this short time frame of about 30 years. So how do we do that? What are the responsibilities associated with building systems, with climate mitigation strategies and passive and renewable sources and strategies that we can put in the built environment would be the question that I would always want to answer. When we think about climate resiliency, which is a very good question that we have as part of the panel today, we don't have answers yet. However, if we look at energy, we have intellectually solved it. We just need the time to apply it. So we look at hydro here locally. It's very useful. We look at energy in terms of renewable as PV or wind. We see lots of great technologies and better efficiencies and very cheap prices for panels that you can integrate anywhere. So looking at energy is just a matter of time to implement what we have seen intellectually solved. However, when it comes to climate resiliency and alternative construction methods that we see problems with, for instance, we look at concrete to be a thermal mass good material. However, it is a very bad when it comes to carbon footprint. So replacing this material with alternative constructions such as straw bale or adobe or any kind of rammed earth made materials and the likes, mass timber, which is not quite there in terms of the construction, but because it still needs some like topping with concrete and other things associated with that. We look at the building codes, they don't have any recognition of these materials. So the question is, how do we look at implementing resources that would make a positive impact on mitigating climate. However, how do we also solve the dilemma of building codes that would recognize these materials as one of the strategies that we also should talk about? So we'll leave it at that. Thank you.
Thanks, Dr. Araji. Next, I'd like to invite Dr. Jason Gibbs.
Hi, thank you. Thank you for the invitation. I don't normally think of myself as being someone who's working on in climate resiliency. I'm an entomologist, so I study insects. So I'm very much interested in biodiversity, and I also do research mostly focused on wild bees, but we also study other beneficial insects and looking at ways to increase biodiversity in agricultural systems. And so actually, we often think of insects as being pests or nuisances, but there's a lot of insects that actually perform important ecological functions. And so, by taking strategies either in agricultural systems or urban systems that help diversify these beneficial insects, we can sort of increase the resiliency of these sort of important ecological functions that benefit humans. And climate is obviously a major driver and an increasingly important one, and has important effects and impacts on biodiversity. So my research is mostly sort of trying to understand, the diversity of insects that we have in Manitoba and Canada, and then also trying to implement strategies, mostly in agricultural systems, to increase biodiversity to support them. There's a lot of strategies that we can use that will also sequester carbon, while also providing the sort of habitats that support all these beneficial insects. Thank you.
Thanks, Dr. Gibbs. Now I'd like to invite Shannon Mustard, Masters of Sciences student in Soil Sciences.
Thank you, Jesse, and good afternoon, everyone. And also, thank you, Jason, for that nice segue into soil science discussion. I completed my Bachelor of Science in Agriculture from the University of Guelph, and this past fall I began my Master's of Science here at the U of M. I was originally interested in sustainable agriculture, but the issue with that is that we were trying to sustain a broken system that can continue to remain a contributing factor to greenhouse gas emissions. So I then became interested in regenerative agriculture as a method of mitigating greenhouse gas emissions and climate change. And this alternative farming system provides a more holistic and whole systems approach to farming as a way of rebuilding and restoring degraded soil properties, such as microbial components loss, soil organic matter, and structural soil integrity. And regenerative agriculture can play an extremely important role in climate resilience, in building and maintaining that resilience, as well as for farmers' individual land resilience. And some of the practices that farmers can implement into their land management are reduced tillage, reduced chemical use, such as Jason mentioned, because there are beneficial organisms and insects that can contribute to our crop biodiversity as well as our ecosystem biodiversity. And if farmers are able to implement these types of practices, then they can almost provide farmers with a source of soil insurance, similar to how they invest in crop insurance. With the ag system, they work so closely with the unpredictable nature of the environment system and the extreme climate events that they endure are only supposed to occur more often and more intensely within the next couple of years. And so investing time and resource into these regenerative agriculture practices can allow farmers to build and maintain their land resilience, as well as maintain productivity and profitability following any of these extreme climate events that they may experience. In terms of my research or my project, I just began this past September, so it's not underway yet, but it will focus on the effects of cover crops on greenhouse gas emissions, specifically carbon dioxide and nitrous oxide, two of the three biggest greenhouse gas contributors. And cover crops is only one of many regenerative ag practices that farmers can implement. So to conclude, regenerative agriculture is a solid solution for farmers to adapt and adopt certain practices within their land management regimen that can allow them to build their land resilience as well as our global climate resilience and allow us the opportunity to meet these goals that we've set out for 2030 or 2050. So.
Thanks, Shannon. Next, I'd like to invite Professor Lancelot Core, Associate Professor in the Department of Architecture.
Thank you so much, Jesse, and thanks everybody for this kind invitation today. It's really obviously a profoundly important subject, and I feel very privileged to be here, so thank you. Yes, my name is Lancelot Core. I'm an associate professor in the Department of Architecture, and I'm originally from Philadelphia, Pennsylvania, and was raised in the Wissahickon Valley in the indigenous territory known as Lenapehoking. It's the traditional lands of the Lenape people. And my background is actually in engineering. My first 2 degrees were in architectural engineering and civil engineering. And then following that, I studied Masters of Architecture and am now currently a PhD student at Perea University in architectural engineering. And my areas of teaching effectively are centered on the question of design through the studio design teaching that I explore my research in. And I also do a lot of my work in teaching technology curriculum within the Department of Architecture. In the field of architecture, one of the main statistics that guides a lot of my teaching and research interests is focused on the interest and the understanding about the amount of pollution that buildings contribute to, which effectively is approximately 40% of all pollution created by the modern industrial societies that we live in. And often this includes energy consumed to construct our buildings, energy consumed and produced to extract building materials from the earth, and the energy needed to operate the buildings that we design. So when I speak with students in these courses and in the design work that I do in the research, I'm focused on these very specific areas. So not just generally the question about the contribution of the building industry towards creating pollution and extracting resources, but actually focusing on these specific areas of building buildings. What are the building systems we use, and how do we determine what buildings, how buildings can be more sustainable over time? And I also in my work recognize personally that the challenges that we face are created very much by the systems we often operate in, that these modern industrial construction trades and material extraction and processing systems are all mostly responsible for a lot of the challenges that we face with the carbon pollution that we've created and the material extraction we've pursued. So while iterative advances in these existing systems are fundamentally important, I personally am interested in exploring alternative building systems that don't necessarily rely on these same industrial approaches towards building buildings, and try to leverage the intelligence of the natural world to help guide the development of new building systems and ways of working and ways of building. Another part of that is that I believe that we need to look outside of the industrial and modern building culture to find inspiration and guidance towards ways of looking at how communities and cultures used to live in a more balanced way with the environment, and many who are still trying to return to this paradigm today. In my research and teaching, I try to collaborate with many of these communities and to learn through seeking to help with these efforts. So specifically, there are 2 main areas of research that I carry out. One is through working at the Center for Architectural Structures and Technology on the U of M campus, or otherwise known as CAST, the CAST facility. And in this building, I work on developing advanced self-organizing building systems. And these systems essentially use material behavior to guide the design and construction process of building systems. So I'm focused on working with both emerging technologies like parametric design controls and automated machining, as well as ancient technologies to help promote a highly efficient architectural system and building system. The second part of my research works both within CAST, but also within my teaching in Design Studio. And this is through community-based design studios that focus on Indigenous sovereignty in housing design and using traditional and local knowledge to help maintain meaningful connections to the land-based teachings and resource management. Currently, I'm working with the community of Broken Head Ojibwe Nation with Professor Sean Bailey in this particular design studio, and that's part of a larger SSHRC-funded project entitled the Manitoba is Wind Partnership, led by Dr. Shirley Thompson, and also with the One House Many Nations project led by Dr. Alex Wilson at the University of Saskatchewan, and also partnering with the Prairie Climate Center. Thank you very much.
Thanks, Lancelot. Now I'd like to invite Dr. Dan Bayless to speak. And Dan is the professor and head in the Department of Psychology.
Hi, thank you very much for the invitation, and thanks to everyone for being here. So yes, I'm a psychologist, and I'm responding to the title question today as a social psychologist. But really, to a psychologist, resilience always means behavioral adaptation to loss or change. And psychologists tend to study this at the individual or the person level. It's completely clear to me, especially from listening to all the previous presenters, that we need much more than just individual actions to change in order to safeguard our climate and do other important things to protect the environment, like waste management and conservation of habitats, maintenance of biodiversity. So the first thing that climate resilience means to me in my research is that I'm simply not up to the challenge. But maybe my field can contribute to a small part. And the part that interests me is understanding consumerism. So I'm talking here about our cultural fascination with buying things, particularly things that we don't really need to survive and thrive. In Canada, we have a political and economic view of consumerism and related indicators that you hear about in the news, like consumer confidence, consumer spending, and they're treated as practically the measure of health of our economy. And we also have critics of that view who often try to engage the public in understanding sort of the hidden costs for the environment and also for labor and human rights globally. And those critics are trying to raise those arguments in order to change those consumer behaviors. Psychology doesn't really align with either the political economic view or the social critical view. It tends to point to other factors, not just ignorance of the hidden costs, but other factors that could be maintaining these consumer behaviors. And the question for our research becomes, what are the psychological functions of these behaviors? What functions are they serving in the first place? And how can we use that knowledge to promote a reduction in some of these behaviors? And so for me and for my students, we're especially interested right now in a factor called self-compassion. It's basically just another term for being kind to oneself during difficult times. And we've really just begun our research, but the logic of it is that what drives consumerism in the first place is often a feeling of unmet need and insecurity. And consumption is one way to ward off those feelings. Displaying high status is often a part of pursuing it and actually securing it. But there are other ways of handling those feelings. And we think that people being more compassionate toward themselves could be one of them. And so that is something that our research is beginning to show at this point. So maybe I'll pass on to the next person there.
Thanks, Dr. Bayless. All right, last up, I have a recording from Dr. Jocelyn Thorpe. She is teaching at the moment, but she sent in a video in advance. And Dr. Jocelyn Thorpe is Associate Professor with Women's and Gender Studies. So bear with me as I load this video.
Hi, everyone. Thank you so much for including me in today's events. I'm so disappointed not to be here in real life or real virtual life. While my virtual self is here, my actual self is virtually teaching. It's all a little bit confusing. But I'm disappointed that I can't join the conversation because I'd really love to learn more about the work that people are doing in this area. My research is about the histories and legacies of colonialism, and I focus specifically on how environmental justices in the past have led to a status quo which naturalizes into institutionalized injustice. Learning about the past can allow us to think critically in the present and to move toward a future of more just relationships among humans and between humans and the rest of the world. In my few minutes with you today, I've decided to focus on two of the questions that we were given as a panel. First, how can we equitably confront environmental damage in an actionable way within our community? And second, what gives you reasons to be hopeful in our transition toward a more sustainable future? Okay, to the first question. In order to equitably confront environmental damage, or to confront equitably environmental damage, we must recognize that not all human beings are equally implicated in the trouble that we are in right now. It is not human relationships with the rest of the world per se that are the problem, but rather particular human relationships with the rest of the world that are the problem. Relationships rooted in a domination mindset, and which have resulted in the European dispossession of indigenous lands, the trade in enslaved people from Africa, the transformation of territories in the name of progress, profit, and civilization, and of course, anthropogenic climate change. When I think about the word resilience, I think now about the anti-racist podcast, Don't Call Me Resilient, hosted by Vinita Srivastava. The idea behind the title is that an emphasis on resilience can take away from focusing on that which one should not have to be resilient about. The title was inspired by Tracy Washington's response, she's a lawyer and an activist, to President Barack Obama's call to be resilient after the devastating impact of the BP Deepwater Horizon oil spill. She said, "Stop calling me resilient, because every time you say, oh, they're resilient, that means you can do something else to me." I like this example because it shows the connection between the exploitation of fossil fuels and injustice. So often it is Indigenous and racialized communities which disproportionately bear the brunt of environmental degradation, that are expected to be and are celebrated for being resilient. But the point is that we need to stop doing the things that require people to be resilient, even as we can also recognize the need for resilience in the face of environmental change. If we are not transporting oil in pipelines across Indigenous territories, we need not expect those communities to be resilient when the pipelines inevitably leak. Building more resilient pipelines is not enough. We must stop the onslaught. I think too about Ursula Franklin, who refused to be part of helping to dispose of nuclear waste until the government agreed to stop creating nuclear energy. This is such a strong and brave message that the status quo cannot remain in place for real change to happen.
So Dr. Thorpe has led us to our next question in the panel discussion. So I'll open it up to other panelists. And the question is, how can we equitably confront environmental damage in an actionable way within our community? And whoever would like to get started, go ahead and unmute yourself.
Guess I could start. This is Dan Bayless. So I guess, I want to be mindful of the problem that an individual level analysis from psychology doesn't always translate directly to the community level. But at least in regard to consumerism, if our analysis is right, then equity itself will confront or counteract some environmental damage. And I think that aligns with what Dr. Thorpe was just saying. A more equitable society is a more secure one. It's a society with a growing gap in wealth and income between, let's say, the top 1% and everyone else, in which people's status and security and then consumerism both rise together. So I think it's possible that a more progressive or redistributive economic policy position, a better social safety net, more affordable housing and available public transportation, more equal opportunity employment, all of these things could have the byproduct side effect of reducing some of the environmental damage that is occurring, at least through our culture of consumerism.
Thanks, Dr. Bayless. Would anyone else like to speak to this question? I can also move on to the next.
Well, I mean, it's really way outside of my area of research, but I mean, I guess to change it slightly, perhaps. I mean, I sometimes think of just we sort of have to take responsibility and not put certain changes on other people. I'm sort of viewing this from the agricultural perspective, I suppose. But we have this sort of system that we've created for, for efficiency purposes to sort of create these large sort of agricultural fields where we sort of create these sort of monoculture crops so that people can sort of grow food in the most effective and cheapest way possible. We do that so we don't have to pay higher prices in the grocery stores. But at the same time, it's pretty hard to put that all on the farmer, because they're just trying to create something that they can feed their own families. And so I think we have to sort of collectively kind of come together and try to make sure that we sort of have these sorts of more sustainable systems in place, and we can't sort of just sort of allow that sort of free market sort of to do that, because it's always going to pick the cheapest and most efficient option at the time. And so I think we have to sort of plan ahead and hopefully create systems that's going to be create food security and that's works for everybody.
Thanks. It's a big question for just a couple of minutes, but an important one. I'll move on to question 3. The design and construction industry still accounts for a significant level of environmental degradation and GHG emissions annually. What are some regenerative and alternative strategies that could help reduce environmental impacts that you're familiar with through your research or practice?
Well, I can maybe provide my own view on that. I think that one of the things that I've been involved with students in the past in working with communities, specifically rural communities and First Nations communities, has been about looking at the existing housing stock and material stock of structures that we already have on the land. One of the biggest problems, and I actually appreciate very much, I really like this interdisciplinary or cross-disciplinary conversation, because Dr. Bayless, talking about the appetite for consuming, and in a way sort of suggesting in some sense that the definition of progress means producing new and more and growing rather than sustaining and actually making better what we already have. This speaks to me because this actually talks about the opportunities that we've taken where we've worked with communities like Clearwater, Manitoba to take we've worked with 8 different buildings in that community, century-old structures that have been abandoned over time for various reasons, mostly depopulation because of industrial scale agricultural practices, and it's all connected. And we've worked with those buildings and the community to deconstruct them from the top down and to try to salvage as much of the old growth lumber as possible. And then we use that lumber to work with the community themselves to determine what new structures would actually be useful these days. And so what's really profoundly interesting, number one, is that by working with existing building stock, number one, we re-understand what already is in our landscape, and we also perpetuate and extend the value of the materials that we've harvested from the earth, and we extend their life cycle, and we start talking about the idea of what happens after the initial perceived use of a structure. So I think it's really taking a bit of an accountability and responsibility for understanding that we are actually responsible for thinking of after our initial life that we typically project to. The other thing that I think is really interesting is that those practices actually connect us to the communities that those buildings have stood in for a very long time. So very often the stories that come out through the dialogue and conversations working with the community members, you'll hear about the stories of the community, and then the work itself becomes about a way to link with those who live with these structures on the land. So I think what I'm trying to say is that certainly we can be talking about full life cycles of building practices, thinking about how buildings and material systems can be, yes, it is violence to build architecture. We have to cut things down, we have to dig up the earth, and we have to produce pollution to create building materials. But that doesn't mean that those structures have to be used just once. We can try to extend their life and try to make them as useful as possible for the longest period of time and use them as ways to connect with the communities.
Maybe I can add to what Lancelot have introduced, which is very important. The concept of the life cycle in general is based on 3 phases: the construction, the operation, and the demolition of a project. So if we take the construction, we are interested in how we can reduce the carbon footprint of the building materials. And for this, alternative construction shows up. And then also when it comes to operation of the building, we have to look at systems and the specifications of materials, again, that would make a reasonable insulation to the building, especially in harsh climates as we are in here. So the carbon footprint of materials, if we look at concrete, steel, and wood, which what we normally have in our building code that recognizes only mostly these materials, in addition maybe to CMUs like compressive concrete units that we apply in buildings. So concrete has a high thermal mass, so it's a positive thing for energy. It stores heat that is generated by radiation from sun, and then eventually it dissipates this into the space, and we can benefit from that. But we look at the carbon footprint of the material and how it is made. It is very difficult to convince. It has a high carbon footprint. We look at steel. They mentioned that it has a high recycled content recently, which is good because it cuts on the ore part of the material. But again, when it comes to how you melt it and how you mold it to put it in structural systems that you can use in buildings, it has a high carbon footprint. We look at wood. Wood is good, especially if it is resourced from managed forests. And we are here lucky in Canada to have mostly this kind of approach. This is not necessarily a global application elsewhere. Now, this is a brief comparison on what the building code recognizes in terms of building materials. But now we look at alternative construction, such as the ones that I introduced, rammed earth, adobe, cob, the stack wall, and the log construction. There are like so many methods that are very famous, but the code doesn't recognize. And this doesn't mean that you can apply them according to the code. You can still apply this, but you have to go through a process to approve the materials so you can build with it. So I think one of the challenges that we should solve is how to make the building code recognize some of these alternative construction materials. In terms of the operation of a building, we have to look at the systems, and systems here has a big impact because we have changed our approach for occupying a space. I give a quick example. Better Learning Spaces report by RIBA, the Royal Institute of British Architects, in a recent report, they have evaluated about 60,000 schools, and they have looked at the performance of these schools and how it copes with the target performance that they were designed for. 95% of these schools don't meet the performance target that they have established their designs on. And there are so many reasons for that. In another study in Germany, they look at schools that implements different sizes of classrooms, different building systems from 1890s to current schools. What they found that the school size has become smaller, so it used to be about 80 meters square, let's say, per 20 kids. And it's now becoming 60 meters square per 20 kids. The height used to be 4 meters, and now it became 3 meters. The layers of the construction that they used to have is almost like one material, and it's very simple. Now we're complicating buildings. We're putting 3-4 materials, if not more, to put the envelope. So it is all complicating the assemblies and therefore creating more carbon footprint for these assemblies. And when it comes to performance, the previous buildings in the 1890s was meeting better performance in terms of air quality, in terms of no use for mechanical systems. And the recent buildings, they are using all of that. And as a result, they are generating more carbon. So if we look at our approach in terms of surface area to volume ratio, it becomes a big problem on how we mitigate this. So I will leave it at that for now, just because creating a comparison between the two stages and what is really needed to be done for both of them. So building systems in operational and carbon footprint in alternative construction with the building codes.
Thanks, Dr. Araji. Good points. I'll move on to the next question. What gives you reasons to be hopeful in our transition towards a more sustainable future? Where do you see new advancements being made in the field of climate resilience research? And I'm going to open it up to Shannon and Dr. Ho first.
I'll go first if you don't mind, Dr. Ho. What really excites me and keeps me hopeful is that the ag industry has a really unique opportunity at the moment where they are looked at as the problem, but they are also presented as the solution to a lot of greenhouse gas issues and climate change issues. And I think now is the time to lean into that opportunity for innovation and creativity and to have cross-disciplinary discussions such as ones like this, where we're able to form solutions to a global issue. This one impacts us all, regardless of what industry or sector we're in. And a quote I heard the other day that I find really resonates well with climate resilience is, everything that needs to be done is being done somewhere and being done successfully, but we need to see things being spread ubiquitously. And that was by Roger Martin from the University of Toronto. And he makes a really great point where regenerative agriculture has been done in various geographical locations and it has been successful. It's just a matter of farmers being consistent with their implementation of these practices and farmers being disciplined, and they will see the rewards and their profit and productivity improve in the third or fourth year, even though their yield may decrease in the first couple of years. But it's like anything new that you do in life, right? Say you start a new diet, you can't expect it to work within the first week or so. You have to be consistent and disciplined. And in terms of technological advancements, precision agriculture has made such great headway within the last decade, and I can't even imagine where it will be in the next decade. With tools such as GPS and GIS and models such as HOLOS and DNDC, and these models specifically provide farmers with an estimate of their greenhouse gas emissions and an estimate of their profit, loss, and gain. And I think that's an extremely valuable tool to farmers, as it can provide them with a visual of any gaps that may be in their production system, and they can adapt or adopt new practices, such as any regenerative ag practices that could lessen these gaps. And as long as they're continuously improving these gaps that they may find in their production system, then they're on the right track to building their land resilience and building global climate resilience overall. So.
Thanks, Shannon. I'll leave the last word with Dr. Ho, and then I'm going to open it up to questions from participants.
Thank you. I can give a very short comment about this question, or two questions. For me, I'm a person who is always hope the best and then also prepare the worst. I believe for this one, I do not have any scientific reason to support that. I just have the following reason. I believe everyone loves our Earth and also our next generation, and we will find the right path to move forward with a more sustainable future. From history, different generations of scientists and also engineers, they make a lot of breakthroughs in technologies in the last 100 years to improve our daily life. And also people also solve a lot of problem, and also to get rid of crisis, and also adapt a new environment, a physical environment, I mean, and also economical environment after a lot of crisis. So that's why I think that we can solve the problem, and also the technology and education will help us adapt it smoothly. And one thing that is very good for, I'm talking about education, for my sons, they are in elementary school, and then they have already talked about sustainable energy, renewable energy, and also always ask me about electric vehicle, what is the advantage or something like this. I think it sounds very good, you know. Food education, they try to improve the earth, or try to improve everything for the future. That is full of hope. And also, and another question is talk about the what is the new advancements, and I think that the commitment of net zero greenhouse gas emissions by 2050, this movement, is a big progress of climate resilient research for this one, because it's successfully to draw a lot of scientists and also researchers attention, or also for a lot of other people as well. And then something like this, we can bring everyone together to discuss and also generate other research topic, and also a lot of collaboration as well. So I think that is a big progress, and also I can see more research in the future. Thank you.
Thanks, Dr. Ho. All right, I'll open it up to questions from the audience, and Zainab has had his hand up, or has their hand up, and would you like to unmute yourself and ask the question?
Yeah, good afternoon. Thank you for having me. I'm calling from Winnipeg on behalf of the Canada Sierra Leone Friendship Society, Inc. Global climate change is real, and we need action. If I remember, I was schooling with Al Gore while we are doing this research, following, and we see a lot of actions. We see a lot of reactions, in particular in Sierra Leone, West Africa. COVID, well, is the last one, like the mudslide and Ebola, lot of affection. Presently, our organization, which is Canada Sierra Leone Friendship, doing agriculture. You see a lot of insects spoiling the plants. How can we see it's real, we seeing it affecting both national and international. Which action shall we take? And are we just continue doing research, or we need to take immediate action so that we can fight to conquer it? Like in poor countries, they need financial. In international, we need international to intervene, to work together, ideas and action taken. But climate change is real. Thank you.
So, thanks for your question. I'll try to reiterate. And so you're asking what immediate actions can we take nationally and internationally? And I think, yes, I think each of our panelists would have something to say on this, but maybe I'll open it up to one panelist to try and respond.
Well, I'll say something. It's a profoundly important question. I think. Thank you for that. I think number one, we need to have that kind of initiative and realize it's urgent, and realize that it's actually something that we can think about and we can research. But really, what matters is actually applying the research. So I would say one big thing we can be doing is trying to be involved in the global challenges that we have as the sites for our research. So not just staying within our own silos and in our own safe spaces to carry out the research. Certainly that has to happen, but I think the more and more that we can actually use our privileges in different parts of the world as universities and research institutions to try to reach out and connect with communities that can use assistance and use help, that actually is a way that we can use the challenges that are active to teach the institutions like universities about what is actually going on and what actually we can use to make progress. So I think that what I'm trying to say is using these immediate challenges can be sites for advancing research as well. So it can be a self-feeding thing that we can be working with industry, but industry is also trying to make profits. So academia has a unique place where it's in between the government, capital structures like industry, and the public. And academia can actually try to build bridges to create solutions as quickly as possible. And I know that there are various scales that can happen, but that's a very kind of rosy, hopeful way to say it, but that's the best answer that I could probably think of.
Thanks, Lancelot, and thanks for your question. I'll move to Shauna.
Hi there. Thank you for the very interesting panel discussion today. I'm a colleague of both Lancelot and Mohamad in the Faculty of Architecture. I would brand myself as an environmental designer that comes from the position that sustainable design is not so much a technological challenge as it is a human one. So I'm interested because of the diversity of the panel and all the different fields one comes from. In fact, I think Professor Bayless has maybe got the most to say about this, but one of the things I find is that we need to remove the barriers to more sustainable behavior. So, I'm not going to carry a tin of Coke after I finish it and put it in the recycling unless I only have to walk a couple meters before I find a garbage can to put that in. So that's a very oversimplified approach, or what I really want to say, and maybe it even talks to the issues of Sierra Leone and the inequities. But what I really would like to ask each panelist is to reflect on, I know what they are in architecture, but reflect within their discipline, what are the key barriers to promoting more sustainable behavior in your field? Whether it's electric car driving or it's about providing bio environments for bugs or better agricultural practice. What is the barrier?
Okay, shall I start? Well, thank you for the question. It's actually gives me an opening as well that sort of tie back to some other things, including the previous question from Zainab and from Dr. Lima's remarks that we kind of went past quickly there, but where he was referring to quality of life. This is something I think is really important to say about sort of hope for the future. That I think for my field, a more sustainable future is also a psychologically happier one. It's like, I want to sort of make that point that, and particularly when we hear about things like pro-environmental lifestyle choices, whatever they may be, composting, recycling, active commuting, using public transportation, eating meatless meals, when we hear these things, especially coming from a Canadian perspective, we imagine that it will feel like austerity. And we have sort of these quick knee-jerk reactions. This, I think, gets to the point of sort of what is really the barrier. You have a reaction like, if I have to do it, it won't be much fun to do it. Or you want me to give something up, so it must be, my goal must be to try to keep it. Right? These sort of simple rules of living. But I think if psychology tells us anything, it's that we are not good judges of how these types of changes will actually make us feel when we do them. And that's, to me, the barrier. It's the same thing when you think about the status quo, like how easy it is for us to normalize and overlook the extent of anxiety that we have day to day. Because, and I think this especially applies to younger people, but to all of us really, because of lack of exposure to green spaces, knowledge of the environmental degradation that's happening in the world today. And so, yeah, we overlook how anxious the status quo is, and we think that the future of environmental sustainability is going to be bad. But this is maybe one of those times where psychological research is really only telling us what indigenous peoples and cultures have known for generations. But certainly what the psychology research would suggest is that when we do make the necessary changes to protect the environment, we're going to feel better, much better. And that's really what sort of gives me hope for the future, is that this will be sort of a virtuous cycle. It will be self-sustaining. Once you start to make the change, you'll realize that it's better and you'll keep doing it. So, my 2 cents. Thanks.
I don't want to cut our discussion short, but I'm going to recognize we're just a couple of minutes past 1 o'clock. For anyone who is able to stay on and would like to continue chatting and answering questions, please do so. And then, but if you have to log off, go ahead and do that as well. So would anyone else like to continue that, answering that interesting and important question?
Yeah, maybe I can say something about this topic. I fully agree about that related to human behavior. That is the that is the main barrier. I think people, they like convenience, and also they care about the money in their pocket. You know, so that means basically the government can do something. I remember when I was in Switzerland, I lived in Switzerland for a long time, and then what they do for the garbage bag. If you want to throw away garbage, and then you have to buy garbage bag, and they are very expensive. So that's why they force people, they try to reduce the waste and also put it in the recycle bin. So this kind of activities or strategy can be done by the government. But of course, in Canada, we do not have this this strategy or methodology to control that. And also for electric vehicle as well. Why electric vehicle is not very popular in Canada? The one reason that is electric vehicle that is in a very beginning of the product life cycle. So that's why it's quite expensive. I think government, they can say, for example, to have some compensation, or say that to give some money to funding to a new buyer to buy electric vehicle, or to increase, maybe some company, they don't like to hear that, or the government can increase the selling tax or for the conventional vehicle, so to compensate to help new buyers for electric vehicle. So this kind of activities government can do, and also to encourage, to make more people to get used to have a sustainable future. Yeah, thank you.
Yeah, I mean, I could maybe just kind of add on to that as well. I might be repeating what other people have said, but yeah, as sort of an analogy, I mean, I know what foods to eat and what activities to do to be healthy, but instead I find myself sitting on the sofa eating potato chips. I mean, it's, we do what is, convenient in the moment, and sometimes at the cost of our own sort of future selves. And I think that plays out sort of globally in sort of climate change. I think from what I've heard today and learned, we actually know a lot of what we can do to make effective change to be more resilient in the future and to lower greenhouse gases. But it's just the inertia that we need to overcome to do these actions. And I think that's something that you can't put on individuals or even small groups. It's something that we basically need sort of governmental action to sort of regulate systems in a way that makes it more convenient to do the right thing, and that probably means voting for better representatives in government or having better people run for government, whatever it might be. But I think it's very difficult for any one person to say this is what we need to do right now, because it's something that we need a bigger sort of picture system to sort of to implement it. But yeah, that's and just sort of to add in an entomological perspective, because I'm an entomologist, but there's entomologists do this probably more than anyone else, but we like to eat insects. Mostly it's sort of a novelty, but it's a high protein source. It's low greenhouse gas emissions, very sustainable, but we don't do it because it's something that's kind of gross. People think of insects as being something. Oh, I don't want to eat that. I mean, even within my own family, my wife and siblings think that I'm crazy if I eat a bag of mealworms. But they're tasty and they're high in protein, low in fat, good for you, but we don't do it. And I think that sort of, overcoming that sort of, psychological behavioral thing is what we need.
I'd like to add something to this. I think it's a very nice train of thought. I firmly believe that the climate crisis, especially where we are right now, is fundamentally a crisis of the imagination. We have not collectively dreamt forward. A lot of the things we're talking about right now are about reactions to problems. How do we, plug a hole in the dike there and there and there and there and there, and it becomes an act of survival rather than the act of future thriving. And I think that we have not yet, as a society, lived in that future condition. The Prairie Climate Center has a Prairie Climate Atlas, or Global Canadian Climate Atlas, where you can pick any community and it produces a chart for the next 50 years of temperatures. You could look at Winnipeg and see in 25 years, wow, we're going to have actually 2 full months of plus 30 degrees rather than 3 weeks. And that, dreaming into what that does that mean to your daily life? Yes, it could be a reactionary thing where we try to put out the proverbial fire and figure out how do we stop it. It's not going to be able to be stopped yet. But what we can do is try to mitigate, yes, but actually think about how can we make whatever scenario that future reality is something that we can find a way to work collectively from, benefit from. In a way, go back to Dr. Bayless, like this idea of actually seeing this not as a problem only, but seeing this as an opportunity to live in a way where we feel better, we find more ways to connect to each other, to be connected to our communities, and maybe to the land as well, right? And so all of these things are synergistic, and it has to be a site of imagination where we work together to do that. The question is, where do we do that together? Because we work so individually and we're working hard individually. The question is, I think, opportunities like this panel discussion, where we learn from each other and we start to see connections between different professions and areas, and also the community, to feed possible ways forward.
I was wondering if I could add 2 suggestions, if that's okay. One barrier that I think we could easily overcome is the relationship between farmers and consumers. And one way that I've found easy to overcome that is by going to your local farmers market. That's something I've enjoyed, and it's not asking a lot. You get your produce while also being able to speak to the person who grows your food, right? You have that connection between what you're buying and who grows your food. And I think that makes you value what you're actually investing your money in so much more than buying it from a grocery store where there's not that face-to-face connection. And personally, I've learned so much from the farmers that I've bought products from. And for example, this past Saturday, I went to the farmer's market and a farmer supplied me with this new type of quinoa, flax, and oat mixture that they were making, and they asked me to try it out and let them know how it is. And I think that's such a brilliant way of sampling your product and asking local consumers to provide their opinion and provide suggestions. And another thing that I'd like to suggest is I urge consumers to challenge companies if you think that a company is using too much plastic, or a company can be more sustainable in this aspect. Like, you should email the company, call the company, and put that pressure on them to change, because you're the consumer, you're buying their product. So if you stop buying their product, then that falls back on them. So I urge you to educate yourself in the practices and the methods that companies you enjoy are using, and see where they can use improvement, because your advice is valuable as a consumer.
Jesse, maybe I would also add one more thing, since Sean has asked for each panelist to contribute to this, and I think it's a vital and critical component of the discussion. I think there are two methods that we apply in architecture that should be more implemented. And the first is the integrated design process, and how we should involve not just the contractors and the consultants and the clients in the discussions of making their buildings, whether it's for a renovation or for a design, like a new design of a project, but rather also the occupants and the users' points of view. So this is so critical that once we are in the process of developing the program for the spaces, the requirements for comfort levels, and any kind of functionality that makes this inhabitation of the building is so healthy, I think we should engage those users groups and occupants. So that's one. Two is, this is a bit also overlooked in terms of application, which is the post-occupancy evaluation. We tend to design our buildings and then not evaluate how they are performing after we finish our job. So in operational time frame or lifespan of the project, we should really look into the first few years and maybe sequential evaluation of post-occupancy of the building, and see if there are like methods that would report properly what the results look like in terms of performance of energy of the project, yes, but also performance of the occupants and how they are feeling. One of the, actually my PhD topic is on balancing human visual comfort and psychological well-being in offices. And, yes, the element of daylighting integration, the element of surface area to volume ratio that we have talked about, which is, again, going back to the question and the findings of how a bigger space for a school learning versus a smaller space is a question that people have found answers for, that would say previous designs and approaches for geometry is much better than what we currently have. So maybe we are limiting our use of engaging well with the spaces that we're designing. So I think these two tools, integrated design process, post-occupancy evaluation, and its sequencing procedure would be a critical component to look into this as well.
Thanks, Dr. Araji. I'll acknowledge a couple of questions that have come in. We don't have time for them at this moment. We're going to sign off in just a moment here, but Joanne Joyce has mentioned the benefits of plant-based diet choices and how that could be an opportunity for each of us individually to combat climate change on a daily basis. And sorry, one more. And Mary Horoidisky is just mentioning, the answers are available, so whose interests are driving resistance to positive change. So that's another question to be considering as well. I want to just thank all of our panelists today and all of our participants for just joining in this excellent discussion from such a broad range of departments and disciplines. I've really enjoyed it and learned a lot, and I thank everyone here for your contributions.
Thank you, Jesse. Really appreciate your presentation.
Thank you very much.
Take care. Have a good day.
For everyone.
Thank you. Thank you, everyone.